Okay, friends, we will solve another question from section review 62, problem 1. A small glass ball rubbed with a silk and gains a 2 microcoulomb charge. Q1 is given. Q1 is equal to 2 microcoulomb. It is plus 2 microcoulomb. Then we change it to coulomb. It will be 2 multiplied 10 to the minus 6 coulomb. And then the glass ball is placed 12 centimeters from the small charge. He is given, or in our book it is used as R. R is given 12 centimeters. So when we change it to meter, it will be 0.12 meters when we divide it by 100. And it says the rubber ball has a charge of minus 3 microcoulomb. Q2 also given. It is equal to minus 3.5 microcoulomb, and I will change it to directly. Oh, let's see it firstly. 3.5 microcoulomb, and it is equal to minus 3.5 10 to the power of minus 6 coulomb. And A, it says what is the magnitude of the electric force F wanted. And B is the force attractive or repulsive. And see how many electrons has the glass ball lost, it says. Let's start with A. Draw this part, let's separate given. And A is equal to F wanted. F is equal to K multiply Q1 multiply Q2 divided by R square. Then F is equal to K9 to the 9, 10 to the power of 9. Column constant, and F1 is 2 10 to the 2 multiply 10 to the minus 6 multiply, and the other charge is 3.5 10 to the minus 6. Since here, as I say, just the magnitude wanted, we don't need direction of force, and R is 0.12, square of 0.12 meters. When you use calculator, you will see that F is equal to here 4.4 Newton. Okay, section A is calculated. Then B. It says what is the force? Since one charge, since Q1 is negative and Q2 is positive. Since Q1 is positive and Q2 is negative, let's check here. Q1 is equal to 2 microcoulomb, and it is equal to 2 10 to minus 6. The distance R is equal to 12, and Q2 is minus 3. The repulsion of plus and minus will be negative, so force is attractive. Force is attractive. And C, it says what is how many electrons has the glass ball lost in the rubbing process. As we learned before, Q is equal to now N multiply charge of electron. Here N is the number of electrons, so N is equal to total charge divided by charge of an electron. Then N is equal to total charge here, 2 10 to the power of 6, 2 10 to the minus 6 coulomb divided by 1.6 10 to the minus 19 coulomb. And here the number of electron will be 1.25 10 to the power of 13. 10 to the power of 13 electron there are. Okay, let's pass another question. The electric force, section review 62 and problem 2. And the electric force between a negative charge paint droplet and a positively charged automobile body is increased by a factor of 2. But the charge R on each remain constant. Force increased 2 times, so we can say that second force F2 will be 2 times bigger than F1, 2F1. So force is increased by factor 2 and charge are same. How the distance change? What will be R2 with respect to R1? If you write forces here, if you write proportion F1 over F2, F1 is K, Q1, Q2 over R1 square. F2 is also K, Q1 multiply Q2 over R2 square now. What it says in our question, it says that F2 is equal to 2F1. So if I write it again, I will write F1 over 2F1 is equal to, F1 over 2F1 is equal to K multiply Q1 multiply Q2 over R1 square divided by K multiply Q1 multiply Q2 over R2 square. I have written one equation for F1 here and one equation for F2, and then I take the proportion of them. Here F1 and F1 will cancel, K and K will cancel, Q1 and Q2 are constant, cancelled, all those cancel. So what we have in our hand, if you write it again, the beginning 1 over 2 is equal to 1 over R1 square multiply, if you reverse the second, R2 square. Or let's write again, 1 over 2 is equal to R2 square divided by R1 square. If we take the root of each side, in order to get rid of the squares, if we take root of each side, then it will be 1 over root 2 is equal to R2 over R1. So as you see here, when you multiply it, it will be R1 will equal square root 2 R2. Means that R2 decreases. R2 decreases. Thank you. Another question. Problem 4, a charge of 6 microcoulomb, 6 10 to minus 9 and then minus 3 10 to minus 9 are separated by a distance of 60 centimeters. Where could a third charge be placed so that the net force on it will be 0? Let's place the charge, friends. Assume that that is Q1 and it is negative. Q1 is equal to minus 6 10 to the power of minus 9 coulomb. And let's put another charge here, Q2. It is equal to minus 3 10 to the power of minus 9 coulomb. And distance between them is given. It says 60 centimeters. When we convert it, it will be 0.6 meter. Where should we put a third charge that on the electric force on it will be 0? Since both negative, I can put a positive charge here. It must be closer to a small one. Let's put a positive charge here. What will happen? Q1 will pull it, so there will be a force in this way, which is F1 3, because that is Q3, and Q will apply this force, Q1. And Q2 also will pull it, so there will be a force to the left, it will be F2 3. So, if it says F net 0, means that F1 3 will equal F2 3. Let's write the forces. Instead of F1 3, I will write as K Q1 multiplied Q3 and the distance. I will say this part R from Q1 to Q2. So R square is equal to, for F2 3, It is again k multiply q2 multiply q3 divided by now. The other distance will be here 0, 6 minus r. So I will say that 0, 6 minus r and square root. Again, there are some cancellation here before calculation. We can cancel k from both sides. We can cancel q3 from both sides. So let's write the equation again. q1 over r square is equal to q2 over 0, 6 minus r square. 0, 6 minus r square. Again, let's write now charges. Q1 is given minus 6 10 to the minus 9 over r square, which is equal to minus 3 10 to the minus 9 divided by 0, 6 minus r square. Here again I can make some cancellation. 10 to the minus 9, 10 to the minus 9, and minus 3 minus 2 I can write here 2. So the new equation is 2 over r square is equal to 1 over 0, 6 minus r square. And if you take root of each side, here and there, then it will be square root 2 over r is equal to 1 over 0, 6 minus r. And then if I cross multiply here, square root 2 will be around 1.4. When I'll multiply it by 0, 6, let's cross multiply that here. It will be 0.84 multiply 1.4r. 1.4r is equal to r. Then send 1.4 on the other side. 0.84 is equal to 2.4r. Then r will be here. R will be 0.84 divided by 2.4. Then r will be 0.35 meters. 0.35 meters or 35 centimeters for the first phase. Yani this distance is 0.35 and the other part is 0.25 centimeters. Another question. That's all for today.